finally finishing this section up today. Talking about some word problems. How do you guys feel like we're doing with this section overall? Good? So if you felt like sometimes, I don't know, I've had some groups that really struggled with all this just because it's so much review stuff at once. So if we need another day, Monday we could take one more day and just have like a work day with an extra practice handout over this stuff. Then the last thing we have to cover in this chapter is exponential and logs. So we should be looking at a test next Friday is the plan. So if I looked at this problem, we have a spherical balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters per second. Okay, so it's not a constant thing. I don't have a balloon that's already filled. I am filling the balloon. So express the radius as a function of time. So I'm asking you to write a function, r as a function of t. So t is the variable here. So I need a formula for how I can find my radius. So if we think about it, let's just talk through a few. At time 0, what's my radius? Okay. After 1 second, what's your radius? 2, because it goes up 2 centimeters every second. So after 2 seconds, the radius would be 4. After 3 seconds, the radius would be
6.
So how am I finding my radius? 2 times 2, 2t. So if I wanted the radius at 10 seconds, it would be 20. Right, part B. If V is the volume of the balloon as a function of the radius, find V composed with R and interpret it. Alright, so in general, does anyone know the volume of a sphere? Four-thirds pi r cubed. I would give you that formula if it came up on test or quiz, so I won't expect you to memorize it. But that is how volume of a sphere is found. You guys know what a sphere is, right? Just like a ball. So that's how we find our volume. I want you to do V composed with R. So I'm asking you to do V of R of t. I want this volume in terms of time, not radius. So what do we plug in for the R? R is 2t. Is 8, t to the third, so we get 32 pi over 3 t cubed. All right. Interpret it. Sometimes this is the hardest part. Interpret, you are telling me, what does this formula give? So this formula finds, what is it calculating? The volume. After, what variable are we plugging in? Well, the original formula was in terms of radius, but now my variable is time. So it finds the volume at a specified time. So if I told you I've been blowing this balloon up for 4 seconds, you could calculate the volume just by plugging it in here. Questions on that one? Let's try another one. An airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile and passes directly over our radar station at time t equals 0. What do you think we should do? You guys want to draw a picture to help us visualize this a little bit? Would that help? What's altitude? Okay. And I told you that's just a straight 1 mile, so that means he's just flying straight. Okay, we're not changing altitude. I am an amazing artist, just so you guys know. Where's my airplane? Okay. It passes directly over a radar station at time t equals 0. So here's my radar station at my starting point. Okay, and now my plane is flying. So A, express the horizontal distance d. So horizontal distance is the variable d in miles that the plane has flown as a function of time t. So d as a function of t. So d of t. Finding a formula for this distance. So at time 0, how far was it from the radar station? 0. After 1 hour, how far would it be? 350 miles. After 2 hours, it would be 700 miles. So what's my formula? Mm-hmm. Express the distance s between the plane and the radar station. So s is this diagonal here. So this would be a right triangle as a function of d. So we have to come up with a formula for this s. Probably not one we can just look at and automatically know, but think about our shape. It's a right triangle. How are the sides related in a right triangle? Okay, we could do trig functions. That's another one. Think more basic. Yeah, Pythagorean theorem. And that way we don't have to introduce the other angles and things. So let's just go with that. So 1 squared plus d squared equals s squared. Okay, to get rid of a square with square root, we know it has to be plus or minus, but can that distance be negative? No. So s is just the square root of 1 plus d squared. You can write it as s equals, if you wanted to write it as a like as a composition, you're welcome to write s of d. But I don't care if you use that function notation or not. You can just have s equals. We're just finding a formula for s with d as the variable. So part C, use composition to express s as a function of t. So I need to give s, but I want t to be the variable instead. So we know s is 1 plus d squared. But what's d equal to? If you really wanted to, you could square 350, but we can't add any like terms, so we might as well just leave it like this. So this would tell me the distance from the plane to the radar station at any given point in time. Questions on that one? Why don't you guys try one? So an oil tanker crashed into an iceberg and has developed a leak. The radius of the oil spill is increasing 1.5 inches per second, and has a constant depth of 1 inch. So express the radius as a function of time. What would that be?
1.5 t.
Okay. We need volume. So what does this spill look like? Yeah, it's circular, but we know it's an inch deep, so it's like a cylinder. Okay. When you are talking about volume of a cylinder, so it's basically like the area of a base times the height. So even if you didn't know the formula, we could figure it out. In general, the volume, this base is a circle. What's the area of a circle? And then to get volume, just take it times your height. Think of it as you have a lot of those circles stacked on top of one another. So we want volume as a function of time. So time has to be my only variable. So I have to plug in something for R and something for H. What is my R?
1.5 t.
What's my H? 1, because it said it was a constant. It's not changing, so we don't need a variable. All right, so now we just simplify. What's 1.5 squared?
2.25.
We have our pi t squared. Part C, interpret it. What does this formula give us?
Give the volume of that will spill over at a certain time. So at any given point in time, I could calculate how much oil has spilled out. All right, last one. Read it and see if you guys can get this one. A stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 46 centimeters per second. So part A, express the radius as a function of the time. What would that be? R of t equals 46 t.
All right, we want area as a function of R. What is area of a circle?
R squared.
R squared. I should have said that's a function of t. Hopefully you guys knew what I wanted there. So if I put that in terms of time, I'm going to replace my R with 46t. I don't know this one off the top of my head. What's 46 squared?
2,160.
So if you chose to square it out, you get that. So what does it mean?
If it is the radius of the circular ripple at any given point in time.
The area. Any questions? So that is the end of the sections. So we have that assignment you guys have been working on. So finish that one up. Take your time. Check it while you're in here. See if there's anything that we're missing.